Hello everyone and welcome back to Stat385 for another video. This video we are going to go over Lab 4 and we have what I think are some pretty interesting, or at least more interesting questions to ask in this lab video. Okay, so let's get started. Okay, so I have RStudio open, I'm in my R project, and I have seemingly two directories for Lab 4, whatever. Okay, so I'm going to go to FizzBuzz. And in this quiz, or this problem, we're going to write a function called FizzBuzz, and this is, of course, it's a very strange name, but this is like a specific type of question that interviewers may ask, or programming interviewers may ask, and it's like a problem-solving technique for or problem-solving question for meant to gauge whether or not you know a particular programming language. The idea being that, can you perform these sets of instructions in the programming language of choice with as few lines as possible without errors. So we are going to do this. So the idea is, okay, so we need to write a function called FizzBuzz. Okay, so let's just get started here. Okay, so fizzbuzz.r, save all this. FizzBuzz, oops, okay, in lab 4, got it. Okay, and we want to create a function, FizzBuzz, that takes as input a single argument x, which would be some a numeric vector of length greater than 0. That's how it would be text. Okay, so I have it set up, but I'm going to not use that. I'm going to, or not work within the body of the function. I'm going to, on the outside of the function, do my testing, and then I'll put it inside of the function, and then test it, and then upload it. Okay, so what do we need to be doing? So we're given a numeric vector. I have one declared, or about to declare. Okay, so the function to return a character vector that is the same length as x, which is a modification. So this character vector is going to be a modification of x in the following ways. If an element of x is a multiple of root 3, replace it with the character string fizz. If it's a multiple of 5, replace it with the character string buzz. And if it's a multiple of 3 and 5, replace it with FizzBuzz. Okay, so it may be natural to think that you want to write some sort of loop to iterate through the indices of x and check these conditions. However, we can use principles of vectorization and subsetting to do this task much faster. Okay, so first of all, I'm going to declare, do I need to give this a specific name? No, the output should just be as this. Okay, so I'm just going to call the output y. All right, so, and I'm going to declare y equals to x. So I have x in memory, y is x, and y is going to be the thing that I'm saving. And the reason why I want to do this is because I'm going to change the elements of y, some of them to type character through, or once I change an element of y or add a character string to it, it's going to do type coercion and change the whole thing to character vector, and I want to do numeric checks for these divisible things. So I so I want to create I want to like disentangle x from the numeric vector from the result. Okay, so what can I do? So what if I did something like 3 equals 0? So this should give all of the numbers that are divisible by 3. So the vector x is just the integers from 1 to 100. So I see 3, 6, great. Okay. x5, that should be 5s. 5, 10, 19, 20. Okay, so that seems to be working. And then I could do both, just for, and I'm going to, because I like the parentheses, do this. Okay. Let's see, does this isolate 15, 10, 11, 12, 13, 14, 15? 28, 29, 30. Okay, so this seems to be doing the right thing. Okay, so then, right. So, one way to do this is I could give this index vector names, but what I want to do is I want to use the fewest amount of lines possible. So I'm not going to give these things names and then use them down the road. So I could call this div3 and then do something like y div3 and then make my changes. But I'm just going to do this directly. So y, so now, okay, so x is my numeric vector. I'm pulling out the indexes of the elements of x, which are divisible by 3. Y is x, but it's going to be our result vector, and these are the things I'm going to change to fizz, right? If an element is a multiple of 3, replace it with fizz. All right. Same thing for, this buzz, y elements divisible by 3 and 5, fizz buzz. So note that there is an ordering here. So if I were to do this one first, then as soon as I get down to, so if it's divisible by 3 and 5, then it's also divisible by 3. I'm just going to overwrite it, and then I would overwrite it again. So this one does have to appear last. Okay, so let's run it. Okay, and then see what we get. Let's data frame x, y. Okay. So 3 is fizz, 5 is buzz, 6 is fizz, 15 is fizz buzz. Okay, looks like it works. Okay, so I'm just gonna do this. Oops, I forgot one. I can, okay. All right, and then return y. All right. Fizz buzz. X equals 1 through 20. Looks good. Okay, great. So I'm going to try that. Just to, I usually like to get myself, okay, anyways. All right, so fizz buzz function. Okay, good. I used the right hyphen here. All right, so let's get that and put it here and save and grade. Please work, please work. 12 out of 12. Awesome. All right, so that worked. Good. And now assessment overview, generating a weather forecast. Fun. Okay, so let's see, what do we have to do here? So a lot of text on this. I'm assuming you can pause and read it. I'm not gonna go through all of it. So let's see here. So what I want to do, well, actually I will, but just I guess kind of slowly. Okay, so I want to all requested code in an R script named weather.r. So let's do that. First, weather. Okay, and then we are going to write functions which together can be used to generate a weather forecast. So we're going to probably do more than one function. Okay, so we have a function called next day weather, which takes a single argument current. Okay. And the function should return a numeric vector of length 1, which represents the following day's weather. To calculate the following day's weather based on the current, we're going to use this table. So this is like not exactly, as you can see, like an accurate forecasting system for the weather, but it's just a simple table of rules to test programming ability, namely with these probably some sort of nested else if type logic here. Right, so if we were going to do an actual weather forecast, we'd want to use some sort of probabilistic model using a bunch of inputs, but we are not going to do that here. Okay, so next day weather. So the function should return a numeric vector of length 1, which represents the following day's weather. So, okay, so let's do if current is less than or equal 70, then we want current plus 3. And I'm going to just put the return statements inside this chain. Okay. So now, else if current is less than or equal to 72, we're going to do current minus 1. Okay, so one little note here. Actually, let me get into the next one. No, I could say it now. So if I have like 68 as my current value, then this is true and this is true, right? But this this sort of chain will short circuit at the first truth and then do the task, and will ignore the rest of them. So it won't like keep overriding itself and run the logical chain. So it's at the first instance that the condition is satisfied, that's what gets done, not later instances that also satisfy the condition. So this is written in a very particular way. It's kind of natural to how the table works, but it is actually more sophisticated than what it appears. Okay, so yeah, so between 72 and 74, we get x plus 1. Okay. Now we are in tediousness. Current less than or equal to 76. What do? X plus 1. 78. X plus current plus 3. 80 minus 5. Else current, return current minus 2. Okay, so let's just try this out. Current equals 90. So if you go down here, you can see that the first day will be 90, so it should kind of make sense. Okay, what we get? Oops. Oh, right. This actually works within the function. Let's just... okay, well... Okay, let's see... Day weather, current equals 90. What? Okay. Okay, get 88. Okay, not the best practice here. Let's do 75. 75 is between, so it's less than 76. I should get plus 1. And let's try 71. So this should be 70, right? Yeah, okay, good. All right, so it looks like it works. So technically, if I were doing this a little bit more carefully, then I should remove these return statements and do it outside the body. Yeah, okay. So we have next day weather. Seems to be working. Okay. All right, so then write a function named generate forecast that takes as input 2 arguments. First day, a numeric vector of length 1, which represents the temperature on the first day of the forecast. And num days, a numeric vector of length 1, which represents the number of days for which you will generate the forecast. The first day is included as the first day of the forecast. Okay, good to know. And the function should return a numeric vector of length num days, which contains the following forecast, which contains the forecast for each day. So this is what we want this to look like, and this is what the output should be. Okay, so the previous problem may have been tempting to write as a for loop because, and then we can demonstrate how we can do things much faster and easier using the natural subsetting and kind of the vectorization directly to do things much faster and easier. Maybe it's not intuitive first, but this question, I contend, actually does require a for loop because the task that we're trying to do involves successive elements of a vector in its at each iteration. So it's not like we can just apply a particular function to one particular element in a way that is like natural and direct. So I do contend that a for loop is going to be appropriate. Okay, so let's get a handle of what, okay, so we want to do, so we have our next day weather function. So we're going to be using that. And so I could do current equals 90, and the next is 88. So you can kind of see what's going on here. So let's just take current equals 90. Okay, so how do we want to set this up? Okay, so num days, let's just use these. Actually, okay. So we have first day equals 90, num days equals 10. So let's create, again, it doesn't look like the function is returning a numeric vector of length num days, which contains the forecast for each day. That's not necessarily a named numeric vector, so we can just call it y. Okay, so y equals double length num days. So this should just declare a basic double vector. We have, oh geez, silly me. Okay, so we have 10 zeros. Okay, good. And now we want to initialize the first one to be first day. All right. Okay. So now for day, I can use whatever I want as sort of the index variable. Normally it's like I or j, but here I'm just going to use day because it's fun and natural. To num days. Okay, so what did this do? So I already have the first element of this vector should be the first day. So I don't really need to do anything to that element after I've declared it. So I want to apply, I want to use this next day weather on the previous day to, but that input on the previous day is going to give the output for the current day or the current index. And so the first one's already declared, I need to start at 2. So that's what this is doing. So, you can see it here. I'm going to do, yeah, those are the days that I want. Okay, so then y day should be next day weather current equals y day minus 1. That makes sense? Okay, so let me just collect everything. First day, y, okay, y, okay, run, y, 90, 88, 86, 84, 82, 80, 75, 76, 77, 80. Looks good. Of course, we could do 75. We can, I don't know if it's right, but it at least ran. Okay, so what do I need to do? Okay, so I need to start, okay, I need to actually start making a function now. What is it called? Generate forecast? Okay. First function up here, I got away with being a little bit careless with these return statements and just kind of like put it in and guess and check. This one, I am glad I didn't even create the function and just went straight into the coding aspect on the outside. And now let's just wrap it all into a function. Okay, function, and I need to have the argument first day and the argument num days. Okay, we can do that. Okay. That doesn't need to be there. So I declare my output. Declare my output vector, initialize, and do all this. Okay, great. And just to be careful. All right. I think it's probably good. Okay. Let's try it. Save and grade. Did I do it? Good. Good. You know, I get anxious about this autograder too, even though I'm like sometimes I'm very, very sure, but nonetheless. Okay, last problem, and maybe the most interesting problem. So we are going to create a function that checks an input word against the truth in the popular game Wordle. That's a popular game. I personally don't play it, but this will definitely demonstrate some nice programming concepts. And then here are some pretty cool, mathematics videos surrounding this this game that are interesting to check out. Now, granted, note that the person who makes these videos spends a lot of time for a short amount of material, where it's not exactly feasible for me to have that kind of production value output with the amount of contents that I have to produce for this class. Keep that in mind if you do watch these math education videos, which are great. Okay, that being said, so we are going to, and then, if you want to, you can go play the game to get a handle on it. Pause the video, play the game. Maybe you're playing the game right now, I don't know, and have this on in the background. But either way, we'll write a function that is related to this game. Okay, so let me create a new script. What do I need to do? Write all requested code in an R script named wordle.r. Fun. So let's do that. Save here. And we're going to write a function named checkWordle, which is going to take 2 input arguments. Guess, truth, and then interesting code. Okay, so guess is a character vector of length 1 containing a string composed of 5 capital letters, and the truth is a character vector of length 1 containing a string composed of 5 capital letters. Okay, so character vector length 1, 5 capital letters. Got it. The function should return a named character vector of length 5. The name should be the individual letters of the guess vector, and the element should be green if the name of the element is the letter of the true word at the element's index, yellow if the name of the element is the letter contained in the true word but does not match the position, and then caveats, gray if the name of the element is not a letter considered in the true word. Okay, so using the true word list in a guess of light, so guess is light, truth is list. So we have named vector corresponding to the letters of what was guessed, and you can see the first 2 letters were 100% correct. Green, green. G and H did not appear in lists, so they're gray, and then T is correct letter, wrong position. Okay, fun. So, okay, so I want guess. Let's just work with this case. Light truth equals lists. Okay, so here's a function. Wait, give me 1 second to get the actual string split R. So basically what I want to do is, this is going to be something that we haven't seen before, but we need to use a built-in function in R to take these two things, which are character vectors of length 1 with 5 letters, and then get a character vector of length 5 where each element is a particular letter. So we need to split the string. And I believe that there's just a function which does it. Let's see. Guess. What happens when we do that? Well, gotta declare it. Split is missing. Okay, let's get the documentation for this. All right. Usage. Split. Character vector objects which can be coerced. If empty matches occur, in particular if split has length 0, X is split into single characters. That's what I want. Okay. Split equals, in particular if split has length 0. Maybe that. Yeah, good. Okay, that's something with length 0. This actually comes up quite a bit. I know that this is all very new and you're just thinking I'm pulling it out of thin air, but I've worked with this kind of stuff with like a paste function before, where if you want to paste things together and you don't want any spaces between them, then yeah, this kind of trick has worked before. So I'm not fully pulling this out of thin air. Okay, so type of, looks like it, okay, it does a list. Okay, interesting. All right, so let's do, what do we want to call this? Guess vec. Okay. And we want truth vec. Okay. So let's just see what we got here. Let's run this. Light lists. Okay. So now we want to kind of check, or we want to check which letters are from our guess are in the truth vector. Okay, so there is something that we've seen from lecture to do this, which is very, very nice and helpful. Guess vec in truth vec. And so this will check individually whether or not the letters in guess vec are individually in truth vec. Oops. Give me one. Oh boy, what is going on here? Okay. This will work. Okay, there we go. I needed to convert this into vector. One way to do it is use some built-in functionality in R. Again, stuff that looks like magic, but I'm glad we're going through it together. Okay, so I have my guess vec, my truth vec, and I've taken the length 1 character strings, split it into a length 5 character vector. getting it into in vector form, not in a list. And then using this in function, I can get the indexes of guessVec, which appear in truthVec at some place. Okay, so now what I can do is create a new vector, y equals character length. Okay, I'm pretty sure that's 5, so I can just use 5. Okay, so then I'm going to y this condition equals, you know what? Actually, I want to do if else y, or sorry, if else condition. Okay, if else condition, so if it's true, I want yellow. And if it's false, I want gray. Let's see what this does. Aha, there we go. I want to call that y. All right, so, and then I want to, on top of that, go y guessVec equal to truthVec equals green. Make sure it's spelled correctly. Okay. So let's see here. Y, and then what do I get? Okay, so green, green, gray, gray, yellow. It's correct. The problem is that it doesn't, it's not named vector. So names y equals guessVec. Aha, there we go. All right, so now I can see, now I have output that's meaningful for my guess and is very, very readable. And I can see, based on this output, exactly sort of what needs to be changed in order to make a better guess in the next round. Okay, so we need to wrap this all into a function. Well, I already have it, great. All right, and then return y. All right. I don't need this. Okay. And then I'm going to add some comments to this. Split inputs into length 5 character vectors. Check the guess against the truth. Check the guess against the truth. And some of these are a little bit not necessary, but okay. Looks good. All right, so, oh yeah, let's just test it. Guess equals light. Oops. That would not have been good. Truth equals lists. Oh. Yep, there we go. Great. Equals. Cool. Okay, nice. All right, so looks like it works. So let's try it. Run it in our auto grader. Okay, Wordle. Is it, I gave it the right name? Yes. Man. Man, this is slow on my end. Can only be graded once. Yeah, I get that. All right. Well, we are just... Did my internet go out? Okay, good. 100%. I see something on my assessment and overview. Okay, got it. Man, I get... Does everybody get this anxious of the auto grader? I think it adds a little bit of pressure when you're filming yourself. That's for sure. Okay, so anyways, okay, so we got it. Great. So yeah, I mean, I think these are. I know that we had to, at least for this question, go a little bit beyond the material used in the class to write this particular function. And then I had to employ some tricks from experience on how to supply arguments to those functions, namely that string split one. I don't work with string split very often, but I know the concept must exist in the programming language. And so then it's a matter of just like, okay, well, I've used it before or something similar before. Let's just get to the documentation and then figure out how we use this function and then go to work on it. And if we're being careful and writing our functions like in a way where we can check our work not inside the function body, then we can, update and try things really fast. And then when we're done, put it into the function body. I know in one of the cases I got a little bit sloppy there, but that one was more tedious and not necessarily mentally challenging. So I was able to get away with it. But these other the for loop one for the generate forecast and this Wordle game, it was absolutely, for me, essential to work outside of the function body. And I think that I saved a lot of time by doing that. Okay, anyways, I'm starting to ramble. If you made it to the end of the video, thank you, good job, and I will see you next time. All right, take care, bye.